Hello to all of you, this is Dr. Dhaval Maheta and today we are going to discuss about prediction-oriented segmentation in SmartPLS. So the heterogeneity, which we have already discussed in Physics, another method to it. Heterogeneity, what it is, let us understand. The heterogeneity means, is my model differing in two groups or not? Or is my model having different path coefficients according to male and female or not? Is my model significantly different according to the public limited or private limited or not? So when I'm aware that this may be the reason for the heterogeneity in the model, the researcher is aware from the first day itself, then this type of heterogeneity is known as observed heterogeneity. The second type of heterogeneity is unobserved, in which researcher is not aware, there is some undercurrent which is passing in your data. And now we have to run the algorithm to identify what can be these two segments in which our model is having a different path coefficients. Now, according to the paper which is published by Rust Verhoff 2005 and Vedel Kemikura 2000, to assume in any empirical study that the results that your results come from a single population is often unrealistic. This is not at all going to happen. The second paper, which has been published by JDD et al. 1997, there may be a significant heterogeneity in the data across unobserved groups, and if we ignore it, then we will be introducing type 1 and type 2 errors. So it is a very serious errors which we are introducing if we ignore unobserved heterogeneity. Now this is taken from the book. The example is given in the book of SmartPLS, which has been published by the authors. Now see the path coefficients of perceived usefulness on intention to use 0.4, perceived ease of use on intention to use 0.4. But when we separate the model into two segments, it may be possible that this takes the load of 0.7 and this takes the load of 0.1. Overall, we are seeing the picture as 0.4. The second example is that perceived usefulness to intention use may be 0.4 and this is 0.0. But when we try to find out the reason, it may be possible that perceived ease of use here is minus 0.7 and this is 0.7 and overall we get 0.0. So it is very much necessary that we divide, or rather we segregate the model into two segments or three segments depending upon the algorithm. There are many approaches to latent class to do the latent class approaches in PLS path modeling, or there are many methods of working on it. One of the method we have already discussed, Physics, and the another method is prediction oriented segmentation. Now there are some advantages of prediction oriented segmentation. The first advantage is its basic objective function is to maximize R square in the groups which will be decided by the algorithm while running the program. Just understand one thing. Group 1 and Group 2, these are the two segments which have been identified by the algorithm. Now, how they have been identified? They have been identified on the concept that in both of these homogeneous groups, I am using the word homogeneous groups, the R square will be maximized by the algorithm. So this its objective criterion is to maximize R square. That is, explain variance of all the endogenous latent variables in PLS path model. First, this was the first advantage. The second, it includes a new distance measure. It's having a new distance measure that is very, you can say, very appropriately used for formative constructs. Third, it reassigns observations only if reassigning observations improves the objective criterion. Otherwise, it will not do it. So this is the third advantage of it. Now there are some differences between Physics and POS. Let us understand. Physics can work well on reflective construct. POS can work well on reflective as well as formative. Physics can work better with formative construct having high multicollinearity. POS cannot perform well if your formative construct is having a high multicollinearity. Physics works on non-normal data. POS works on normal data. Physics heterogeneity is expected to affect structural model. It means that Physics can address the issues of heterogeneity in the structural model. POS can address the issues of heterogeneity in structural as well as measurement model, also known as the outer and inner model. There are some steps which we will have to understand to observe, to capture unobserved heterogeneity process in SmartPLS. The first stage is that, just see here, select an appropriate approach to cover unobserved heterogeneity. Is the selected approach a latent class or segmentation? If you are going for latent class for this, okay, come to stage 2, apply the segmentation method to define the segments. How many segments you want? 1, 2, 3, 4, that we will see. Now step 1. The step 1 is, just a minute. Step 1 is use several heuristics to narrow the range of statistically well-fitting segments. Now what do I mean by this? Heuristics means a researcher's own decision that on how many number of segments I'll run this. There are no statistical tests available according to McLahan and Peel 2000, the paper published in 2000, year 2000. So the term uses heuristics. It means that it's a researcher's decision that to determine a well-fitting number of segments in the algorithm. Now, for each segment which has been identified, there are some questions which we will have to ask. The first question, which is this one: are the segments substantial or not? It means that there should be enough representation coming from the groups or the segments which has been identified by the algorithm. Say for example, if there are 100 respondents, then if we do the 2 segmentation, at least 50% representation should come from both. If we are doing 4 segmentation, then 25% should come at least from these 4 groups. If we are doing 5, then 20% from all of them. 20% from all of them. So the first question is the segment substantial or not? Now at any moment of time you feel that no, it is not, then you will have to do some treatment on it. Check for outliers, bad respondents, and statistical artifact. Once you achieve that, yes, the segments are substantial, the next level is are the segments differentiable? Can we differentiate? It means that by running the algorithm or by multi-group analysis, can we capture the measurement invariance, or the thing is the significance of difference in path coefficient between segments exist or not? Are we able to capture this thing or not? Right. So that is, can we differentiate or not? The third is we are able to differentiate. Step 3. Then we will go for step 4. So step 2 clear, step 3 clear, step 4 is the segments, are they plausible? It means that we are having the segments which are substantial, which are representing the 2 groups, that is enough percentage is there. 2, the empirical testing, or rather the algorithm is supporting it. The third, whatever we have done, is it plausible? Means, can I give any theory, can I give any construct, or can I give any literature review which says that yes, such type of heterogeneity may exist? So is theory supporting or not? So that is plausible. Then comes step 5, that after doing the segmentation, this is the segment accessible. Step 5, it means that will I be able to do some advanced statistics like carrying out logistic regression or discriminant analysis here or not? Then we come to the stage 5. It means that 2, 3, 4, 5. If everything is yes, then we will validate the results and we will be running multi-group analysis, and then we will say that it is necessary to report the the pooled result, or to report the results according to the segmentations which have been done. Now, how to do this analysis in SmartPLS? Let's see. This is the model which we have already worked upon on previous videos. I will go in calculate. I will activate the prediction oriented segmentation, and here make sure that 2 groups are on, and in Femix, 10 is on. Okay, start the calculation. It will take some time. The results are ready for us. You can just click on segment size and you can see two groups have been identified. We don't know which these two groups are. If we click here on relative, we will come to know the percentage. That is the first part. Are the groups substantial or not? So 53% representation is of group 1 and 46% is the representation of group 2. Very reasonable. We have achieved first, that is a step 2 of being, are the groups substantial or not. The next thing which you should see is click on R square and just see the average R square. Now this average R square should be more than the R square of the base model. I am repeating again, this R square should be more than the R square of the base model, that is without the segmentation. Now what is the reason of it? Just go back to the theory where I had explained that is its basic objective function or is to maximize R square in the homogeneous groups. So if you achieve high R square after doing the segmentation, this R square, which is average weighted R square, should be more than the basic model in which we have not done any segmentation. And that's the reason we say that the average R square should be more than the base model R square. If in any case, if your average R square, this one, is less than the base model R square, then we will infer that there does not exist any heterogeneity in the model. I am repeating again. At any moment of time, if your average R square is less than the base model R square, then we will say that there does not exist any heterogeneity in the model. Now we will see total effects. The total effects is, for example, co-workers, environmental perception, job satisfaction, organizational commitment. This is for segment 1, segment 2 and original total effects. Now quite surprising, there are groups of people or respondents in which the behavior of co-worker is working negative. See, in segment 2, in segment 1 this is positive, quite surprising. If you see organizational commitment in first group, now here it is negative and in second group it is positive. The same thing you can see on the canvas also. Just see the loadings of organizational commitment. This is for segment 1. When I change this from segment 2, it is becoming positive. So there is an unobserved heterogeneity which exists. Now we have to check with the help of multi-group analysis that is this difference so large that I should report the separate result or not. So then comes the stage 3, this one. What it says, let us read. Validating the segmentation result. So researcher may go for multi-group analysis. If the difference is large, heterogeneity is present. If the significant difference does not exist, heterogeneity not present. Now how we will do this, let us understand. In our previous video, we have already talked about this, but let us do it one time more. I will go in segment assignment. I will copy this in Excel format. Copy this. I will go in my original raw data file and I will paste it here. Control V. Case ID, I will remove it, delete. I will save it. The name of the file is HBAT-SAM1 partition. Done. Now I will go in the model and right click on it, import the data file. Now here, HBAT-SAM partition, where I have saved it, just see what happens here. The group will get activated. These are the groups which have been identified by the system. Group partition. Click open. Okay. The groups have appeared. Done. Now directly go in raw file and here, just a minute, generate the data groups. Group. And here activate the group which is there. Group. 2 unique values. Click OK. Now here we don't know what is the undercurrent which is passing. So let us say we will name it as edit. Group 1. Okay. and this is group 2. Click OK. Now again come on the canvas, calculate multi-group analysis. Click here on group 1 and group 2. Start the calculation. Now the results are ready of multi-group analysis. There are two tests. One is parametric test and another is a Welch test. If variances are equal, we see parametric test, and if variances are unequal, then we go for Welch test. Now in parametric test, just see the p-values. Those path coefficients whose p-value is less than 0.05, it means that there is a significant difference in these two groups which have been identified by the system. So in this case, for two groups, the path coefficients are significantly different. Here it is different. Here the p-value is more than 0.05, and therefore we will say that the path coefficients are not so significantly different. Here again we are having less than, p is less than 0.05, and therefore the path coefficients are different. Let us confirm the same thing by confidence interval corrected, bias corrected thing. If there is an absence of 0, we will say that the path coefficients are significantly different. Absence of 0, see, there is no 0 present here. It means that for two groups, this path coefficient will be different. Here there is an absence of 0, that is positive to positive, here negative to negative. So here also the path coefficient of two groups, the two segments will be different. Now here minus to positive, it means that there is a presence of 0 in it, and therefore it is not necessary for this path coefficient to report the separate result. We can work on pooled result in this case. Here again positive to positive, and therefore we will have to report the separate results. Now to get the path coefficient or a separate model, again I go in demo, calculate, PLS algorithm, data groups, group 1, group 2, start the calculation. Once this is done, you can see group 1 statistics are there and group 2 statistics are there. Both the statistics will appear, go in demo, and from here also you can report group 1 and group 2. Now just click on it and you will come to know how far. See, group 1 is 0.033 and group 2 is 0.007. The difference is large, right? So it is necessary that you report the separate result for both the groups. So what the concept is, let us read the last two lines. If significant difference exists, heterogeneity is present. If significant difference does not exist, heterogeneity is not present. So this was all about prediction oriented segmentation. Thank you. You can subscribe to my channel. You can follow me on LinkedIn and Twitter.